Hello dear students, how are you? Today we are going to discuss about sigmatropic rearrangement. In my last video, I introduced you about sigmatropic rearrangements. In this video, we continue this topic. I will tell you some important points and some tricks. So don't skip the video and watch the video till end. I remind you, if you are new to my channel, please subscribe my channel, watch videos and share videos with your friends. Now let us start. In my last video, we discussed sigmatropic rearrangements. I mentioned some examples. Now I show you some more examples here. So first we start. As I told you already, only allylic bond breaks or allylic bond shift. In this case, this is allylic bond. And I also told you that the bond which breaks, we start numbering from that bond on both sides. So we start numbering from this bond, because this is breaking bond, to both sides. 1 2 3 4 5 and 1. Now what happens? This bond shift to this position, this bond shift to this position, and this bond shift to this position, right? And we get product like this, right? In this case, the new bond is formed between 1 and 5. So this is 1,5 sigmatropic rearrangement, right? Now this is some more example. This is another example of sigmatropic rearrangement. In this case, this is allylic bond. So we start numbering from this allylic bond to both sides, right? Now this bond shift to this position, this bond shift to this position, and this bond shift to this position, and we get product like this, right? This is our final product. In this case, new sigma bond is formed between third carbon atom, both sides. So this is 3,3 sigmatropic rearrangement, right? If there are even number of electron pairs, right? If there are even number of electron pairs in the molecule, then reaction is photochemically allowed. Whereas If there are odd number of electron pairs in a molecule, then reaction is thermally allowed, right? Let us see how. We take some example here. In this case, this is a allylic bond. This is a allylic bond. So we start numbering from this bond to both sides. Now what happens? This bond shift to this position and this bond shift to this position, and we get product like this. Right? In this case, these electrons shift to this side and these electrons shift to this side. Two electron pairs involved in this reaction. Two electron pairs means even number of electron pairs are involved in this reaction. So this reaction is photochemically allowed, right? In this case, this is a allylic bond. This bond shift to this side, this bond shift to this side, and this bond shift to this side. We get this product. Now this electron pair shift to this side, this electron pair shift to this side, this electron pair shift to this side. Means 3 electron pairs are involved in this reaction. It means odd number of electron pairs are involved in this reaction, so this reaction is thermally allowed, right? If you don't know what are allylic bonds and vinylic bonds, I will tell you. This sigma bond adjacent to this pi bond is called as vinylic bond, right? Now this bond, other than this bond which is attached to this double bond, this bond is called as allylic bond, right? This bond which is attached to double bond is called as vinylic bond, and this bond other than this one which is attached to double bond is called as allylic bond. The sigma bond at the end of molecule migrates to the atom at the end of conjugation, and sigma bond at the center migrates to adjacent position, right? I once again repeat, the sigma bond at the end of molecule migrates to the atom at the end of conjugation, and the sigma bond at the center migrates to the adjacent position. Let us take an example. This is some example, and this is allylic bond. As I told you few seconds before, that The sigma bond at the end of molecule migrates to the atom at the end of conjugation. So this bond shift to this end, right? And this bond shift to this side, and we get product like this. Right? And if sigma bond is at center, it migrates to adjacent position. In this case, this is allylic bond, allylic sigma bond. So it migrates to this position. It do not migrate to this position. And we get product like this. Right? So this was all about sigmatropic rearrangements. If you have any doubt, you can comment in my comment box. And thank you for watching this video.